Hi, Econ 112. I have great news. Someone heard me in the previous video talking about how I couldn't find fast breaks in Illinois, and they sent me the location of where to find them in a store, and I am so, so happy. And life is good, and everything is going to be okay. I had to share my good news with you. Thank you to the person in this class who emailed me. It's a good day. It's a good day. It's a good enough day for elasticity. So remember that we are in the first part of this course. That means that this is going to be the last chapter that's on our midterm. This midterm is going to cover chapters 1, 2, 3, and 4. Chapter 1 covers the base language. Chapter 2 does the production possibility frontier. Chapter 3 does supply, demand, and equilibrium. Chapter 4 does elasticity. Now, elasticity is the chapter that most people struggle on with this midterm. So if you have any questions with the material, if the homework start to look a little hard to you, if you're having some problems, please come by my office hours. I will work through every problem that you possibly could have, and we can figure it out together. All right, with that, let's go ahead and start getting going. So, what is elasticity? Before we even jump into this, I just want to show you something very quickly, and please ignore my bad handwriting. So essentially what we're going to be trying to figure out from elasticity is, does our graphs look like this, or do they look like this? Here's really what the difference is. So notice on this one on the left, when we have this very steep demand curve, so we have our price, we have our quantity, and this very steep demand curve. Let's say that we wanted to go from 5 units to 6 units. Well, 5 units to 6 units, if we draw this over to price, that's a really large price jump. Imagine that this looks like an arrow. Yeah. Let's go ahead and, yeah. It's a very large price jump in between these 2 points, right? Well, in this, which means that people are very, very okay with the price changes. So we can reduce by 1, and the price can massively go up, and people are still going to be willing to pay a lot for that product, right? They're relatively inelastic. On this side, let's say we wanted to go from 5 to 6 units. Well, if we come up here at 5 and 6 units, what we'll see is that this is reflective of a really little price change. So when the prices change even a little bit, I'm much less likely to buy that good, right? So when I'm still going to buy it regardless of what the price changes are, or I'm still very likely to buy it regardless of what the prices are, we call this inelastic. For example, let's say that it's my power bill, right? Even if the price massively jumps for electricity, I'm still going to pay it because I can't teach without electricity since we're online. I can't do a lot of other things. Electricity is really necessary for my function. So even if the price jumps by this really big amount, I'm not going to change the amount that I demand very much, right? So let's see what we go in. Now in this case, this is what we call elastic. And don't worry, I'm going to talk a lot more about this as we go through the chapter. I'm just giving you the very basic overview so you have in your mind that these are kind of the pictures that we're looking at. We're trying to figure out if we look more like the inelastic picture or more like the elastic picture. Now notice for a very small price change, so this very small price change, I kind of made what was relatively a bigger jump, right? The jump in between quantity is larger than the jump in price here. What these elastic goods are the ones where I'm going to be willing to change my buying patterns based off of just a few cents or a few dollars or very small price changes. Like, well, fast breaks aren't a good idea because we know that I love them at this point. Nail polish. This is the dollar bargain bin nail polish. Okay. I'm willing to buy a good number of these. If the price goes from $1 to $1.50, I'm gonna be like, no, not really, and not buy nearly as much, right? It's not the same case as electricity, where it doesn't really matter what the price is, I'm still going to buy it, which is inelastic. Elastic means if there's a small change in price, if the price of nail polish gets expensive by an additional 50 cents, I'm more willing to walk away. I'm more willing to say, I don't need that. No, thank you. That's too pricey for me, and just go. And these are kind of the environments that we need to think about as we move through the process of elasticity. So let me go to the slides. And I'm going to be moving back and forth in between the slides and pictures this time, because elasticity, I've realized some students do really well with the definitions and some students do really well with the textbook pictures that I include in the slides. But other students need to see it drawn out. And I know that this is one of our more difficult chapters, so I'm going to present it in both ways over the course of the 3 lectures or the 3 videos that are associated with chapter 4. All right, so let's go ahead and jump into it. So what really do you need from this chapter? When leaving this class, what I would like you to know is to be able to define, calculate, and explain the factors that influence the price elasticity of demand. So what would really affect that? You know, the slope of our demand curve, what would affect that? How would we move based upon it? Is it more of an inelastic good or an elastic good? And what does that even mean? I also want you to be able to define, calculate, and explain the factors that influence the income elasticity of demand and the cross elasticity of demand. These are 2 other concepts that we're going to be getting to. We're going to spend a majority of the time on this chapter on the price elasticity of demand. But these other 3, the income elasticity of demand, the cross elasticity of demand, and the elasticity of supply, are things that we are going to cover as well that you will theoretically need to know. Now, I am going to give you the equations for these on your test. So just so you know, the equations will be available. Now, you're not going to be able to go look at your notes. You're not going to be able to go look at your test. You're not going to, or your old homeworks or anything else like that. But I will provide them on the screen that you have, so you have them there to use on scratch paper. So what is price elasticity of demand? So we know that when supply decreases, the equilibrium price rises, right? That's all the way back in the law of demand, that as we have less and less of something to sell, I'm going to have to raise the price of it, right? Which means the equilibrium quantity is going to decrease. We've seen this in some of our earlier graphs. But what we don't know is, does that price rise by a large amount? And does the quantity just decrease by a little? Or does the price barely rise and the quantity decrease by a lot? I'm going to talk about these fantastic fast breaks today because I'm so excited, right? Okay, so this was, I think $1.50, $1.59, $1.50. Okay, now, if we raise the price by a large amount, if I go to $2.50 and Dr. Plemmmons still buys about the same and the quantity doesn't decrease by all that much, then we know that this might be a relatively inelastic good. I might be willing to buy it no matter what the price is. Now, on the other hand, what if it was something like nail polish, where if the price goes from like $1 to $1.25, which isn't much of a price increase, well, maybe that has a really large effect. And almost everyone says, oh, $1.25. No, we liked it when it was in the dollar bargain bin, but like $1.25, no, that's too much. No, thank you. We need to know which one of those 2 situations we're in, or if we're in somewhere in between the 2, right? So the answer is going to depend on the responsiveness of the quantity demanded of a good to a change in its price. So you might think about responsiveness of the quantity demand of a good in terms of the slope of the demand curve. So if we go back to that picture that I drew, where I kind of give you just the basic overview, notice that the inelastic version has a very steep demand curve. People are not very sensitive to price changes because the price can change by a lot and they're still going to buy a similar amount. That's inelastic, very steep demand curve. Now notice that the elastic version, that's not steep at all. It's a relatively flat demand curve where very small changes in price can have much larger effects when it comes to the quantity. We need to think about this as we're continuing forward. And we can kind of think about that as the slope of our demand curve. If the demand curve tends to be really steep, the price rises by a lot. If the demand curve is almost flat, the price barely rises. But the slope of the demand curve depends on the units in which we measure the price and quantity. So to measure the responsiveness, we need some sort of measure of what we're looking at, right? So when we have this picture and we have this picture, I can tell you which one's inelastic and I can tell you which one's elastic, but we need a number or a way to describe this. And we call that number elasticity. If I can say, okay, all right, so this moves by this percentage amount. Okay, all right, then we understand that idea. And then maybe we might say that this has an elasticity value. Maybe one's equal to 4 and one's equal to 1.5. Well, we can compare these together to figure out which one might be more elastic. So when we start doing these sort of equations, we're going to call this elasticity. And it's something that we do have to calculate to be able to understand a little bit more of this information of what we're seeing, right? So it's just a way of being able to calculate things. So what is the price elasticity of demand? This is equation number 1 for us, right? Let me just, we're going to go ahead and write it down on our, you know what? I just figure it's easier to pause it during these times. So we're going to have our, oops, we need, what, pencil, I guess? Oh, no. I'm learning new things right now. I promise I will get better. So we're going to want our price elasticity of demand. So this is going to be equal to, let's go back to what our equation looks like, the percentage change in quantity demand over the percentage change in price. So the way that I tend to write that is percentage change in quantity demand over percentage change in price. Now, these are a little bit of math shortcuts. It's pretty uniform across departments. So your math professor will realize this, your econ professor will realize this. It's kind of a way that we use shorthand to be able to write equations quicker. So our price elasticity of demand is equal to this top term. If we see a percent sign, then we know it's going to be a percentage. If you see a triangle, you know it's change. So together, percent triangle means percentage change. QD, well, Q means quantity, obviously, because we have price and we have quantity. Price is shown by P, quantity is shown by Q, right? So Q with a D underneath it as its subscript, that's going to be quantity demand. If it was an S, then it would be quantity supply. And then we're going to have that divided by our percentage change in price. Don't worry, I'm going to work out a couple examples with you so this doesn't look as intimidating as it is. Because your test will end up having you calculate at least a few of these. So we're going to work some practice problems. So our price elasticity of demand is a units free measure. What does that necessarily mean? Well, notice I didn't tell you that it's like an elasticity of 4 apples or an elasticity of 4 feet. It's just an elasticity of 4. It's a units-free measure. There's nothing behind that. It's just a number that we're going to assign that we're going to call elasticity. The reason why we have it without units is because we don't really want to compare, you know, an elasticity of 4 apples to an elasticity of 4 oranges. That's a little hard to do, right? We want to make something that we can use for all goods so that we can look at the elasticity of candy bars versus nail polish versus cups of tea. Everything has an elasticity associated with it, and if we have a units-free measure, then we can compare the elasticity in between these different things. So the price elasticity of demand is this units-free measure of the responsiveness. The responsiveness means just, oh, well, I had already deleted it. When we have a price change, how much is the amount you buy really changing? If something goes on sale and it's 30% off, do you buy twice as much of it? Or do you not change your buying at all? That's something that we're going to try to figure out with the price elasticity of demand. So we have this information where we're looking at this comparison of the percentage changes. We express the change in prices as the percentage of the average price. So whenever we get, most of the time when I give you one of these questions, I'm going to give you what the old price and quantity is and what the new price and quantity is. What we're going to compare is the average price in between those two and the average quantity in between those two. So we're going to make it relative to that amount. The average quantity and the average price is just taking that new price and old price, adding them together, divide by 2. our old quantity, new quantity, add them together, divide by 2. So let's go ahead through our first example. So in this example, notice that we have prices on our y-axis, so the up and down axis, and we have quantity on the x-axis, the one that goes across the bottom. What we're going to be talking about is just dollars per pizza. So we're going to look at price changes in pizza. Does a price change of $2? If pizza goes on sale for $2, how much more of it do you buy? Do you buy a lot more, or do you buy just a little bit more? That's kind of the question that we're going to be asking. So in this original version, what we see here is that our old price and quantity, so the one that we're starting from, is going to be $20.50. And when pizzas are $20.50, we sell 9 of them an hour. I mean, that's real expensive. That's pricey. I mean, oh, I don't know what I just did. Please stop. All right. So that's a lot. That's a lot for pizza. Like $20.50. I can buy like 4 Little Caesars pizzas for that, right? So maybe they want to consider having a price change. So in this one, what we're going to consider is that they take this price of $20.50 and they decide to make the pizzas $1 cheaper. So we have this difference of $1. So we go down the y-axis until we've had $1 of change at $19.50. So we've decreased our pizza by $1, and this is $19.50. Now, what happens to the quantity? It's $1 off now. Well, what happens with that is that we now sell 11 pizzas an hour. So instead of selling 9 pizzas an hour, we're now selling 11 pizzas an hour. So for a $1 price reduction, we get 2 more customers an hour. Well, that we have to figure out, is that a lot? We don't know if that's a lot. We got to figure out if that's a lot. So we have to look at what these price changes are. What does that mean for the average price and quantity? Well, we see that our initial price was $20.50. Our new price is $19.50. What's halfway in between these two? Well, that's $20, right? It's a 50 cents on either side, so it's $20 is our average price. Now let's think about our average quantity. Our average quantity is going to be in between 9 and 11 pizzas. Well, what's in the middle of 9 and 11 pizzas? That's going to be 10 pizzas. I made this example pretty easy so that we can at least have this common language to learn it the first time. Now, you will have to calculate the averages on your test, where I will give you your new and your old price and quantity, and you're going to need to calculate what the average is in between the two. Now, so we have our $1 price drop, and we've increased our quantity by 2. And we know that our average price is $20, and our average quantity is $10. Our quantity demanded is 10 pizzas. Can't talk today. Well, okay, let's go back to our equation, right? Because we had that fun equation of our price elasticity of demand. Well, how about we just kind of work this out step by step here. So what do we know? Let's write what we know on the left. We know that we dropped the price by $1. So it went from $20.50 to $19.50. That means our average price is going to be $20. We know that this price drop, because the pizzas were less expensive, increased the amount of pizzas that people wanted, right? So our quantity went up by 2. We went from 9 people buying pizzas an hour to 11 people buying pizzas an hour, which means that our average is 10. All right, well, let's solve this equation, the price elasticity of demand, because this is an important equation. Well, you know what? We can kind of do this in 2 parts. Let's calculate the top, and then let's calculate the bottom. And then we're going to put it all together. So first is going to be this percentage change in quantity demand. Well, what does that really mean at the end of the day? Oops. Which screen am I on right now? All right. So what we're going to be looking at, oops, is that we had, what's our change in quantity? We had 2 new pizzas that are getting sold, right? When our average is 10 pizzas. Well, if we have 2 pizzas getting sold, or 2 additional pizzas getting sold, so this is our change, relative to our average, well, that's going to be equal to what? hold on, my little tablet thingy's messing up. Give me just a second to pause. Okay, we know that 2 divided by 10 comes out to 0.2, right? I think I recalibrated it. Hopefully this works. So we're going to take this 0.2. We want it in percentage change, right? So we want this percent sign right here. So we're going to take that 0.2 and we're going to multiply it by 100. Okay, well, what do we end up having at that point? This comes out to what? 20%. So we know that our percentage change in quantity demand comes out to 20%. All right, so we got this top part. We know that this is equal to 20%. Now let's do the second part, the bottom part. Let's do the percentage change in price. Well, we need a percentage change in price. Well, first, what do we need to do? We need to take how much we changed by, so it's going to be the $1, and divide it by our average amount, so that's going to be the $20. Well, when we do that, we end up getting what? 0.05? Yeah, 0.05. Now we want it in percentage change. Notice that we want this percent right here. So let's multiply that 0.05 times 100. This means that our percentage change in price is equal to 5%. So we know that this part right here is 5%. All right, let's put them all together. That means that our price elasticity of demand is equal to 20% divided by 5%, which equals 4. Boom! Look at that pretty 4. We know that the elasticity is 4. Now you're probably like, what does that mean? Don't worry, I'm going to tell you. 4 is good though. The closer we get to 0, the more inelastic something is, right? So if it's really close to 0, well, I'm not going to change at all. My quantity isn't going to change at all for a price change. If I'm close to 0, that means that we can triple the price of electricity and I'm still going to pay it. The higher the number gets, the more elastic we are. So 4 means, okay, I'm actually really responsive to this price change. We had a $1 price change and we got 2 more customers. That's actually a pretty sizable amount when you know that it's a $1 price change and the average price is $20. $1 is not all that much compared to $20. But 2 extra customers compared to 9, that's actually a lot. That's a big change. So this 4 actually signifies something, and this is the basis of elasticity, and it's being able to calculate this. So by the way, please write down, just please write this down, work through the example yourself as well, because we do have these on the test. Now I am in our review day going to record lectures of going through some of these practice problems, but make sure that you know the basics of them before you get to those practice problems. All right. So let's see, we calculated this, we calculated this. Now let's talk about the terminology. So we know we have this 4, this real fancy pretty 4 right here. We know that elasticity is 4. Yeah, we calculated it, we did the thing. But let's talk about the language that we used in this. Notice that I talked a lot about the average price and the average quantity. We had to know what the middle ground was in between our old price and quantity and our new price and quantity. So when we use the average price and the average quantity, we get the same elasticity value regardless of whether the price rises or falls. So we could have raised the price by $1 and gone from 1950 to 2050, and we could have gone from 11 customers to 9 customers because we raised the price and lost 2 customers. Elasticity would have ended out the same in that situation, because when we start to look at that, we're still doing it relative to our average. So if we increase the price by $1, but our average is still 20, and we increase or decrease by 2 customers, and our average is 10, it's still relatively the same magnitude of changes. So isn't that kind of cool? That's kind of cool. We also use a lot of percentages and proportions. The ratio of 2 proportion changes is the same as the ratio of 2 percentage changes. That just basically means that we're going to be putting the percentage change on top of the percentage change in quantity demand over the percentage change in price. That's the exact same as just kind of thinking about the change in the proportion of quantity versus the change in the proportion of price. We're just kind of making this a simpler and easier way to calculate, because it's really important to know, what does the slope of our lines even look like? So remember that I had called this a units free measure. 4 is just 4. It's not 4 apples. It's not 4 trips to the grocery store. It's not 4 feet or meters or kilometers. It's just 4. Since elasticity is a ratio of percentages, it allows us to compare the elasticity between products. I can look at the elasticity from how much I'm willing to pay for a cup of tea, and when we change the prices of tea, how many customers do they have versus how many customers does the store get for candy bars versus price changes in pens? How many customers are they changing? We're able to compare these because we have these measures of elasticity that makes it so that we can compare different types of goods, even if they're wildly different, as well as their buying patterns. And that's just neat. And it's because it's a units-free measure. All right. Now we also got to think a little bit about the minus sign, right? So technically the formula can yield a negative value because prices and quantities move in opposite directions. But we're concerned about the magnitude or the absolute value in these changes. So it might be a decrease by $1, but I'm still going to say that we had a $1 price change. Because whether we increase by $1 in that situation or decrease in $1 by that situation, the elasticity is going to be the same. So we just kind of assume that we can talk in positive numbers of, okay, well, this is the amount that it changed in customers and this is the amount that it changed in price. Because we're caring about the magnitude when we're calculating elasticity. So we need to think about inelastic versus elastic demands. They can be very, very different. Notice that I gave you the number 4, but what can the numbers really be? Well, they can be as low as 0. In the case of 0, we're perfectly inelastic. That means that I will pay for 4 hours of electricity, whether you charge me 5 cents, $5, $5,000, $500,000, I'm going to pay the same no matter what the price change is. Or I'm going to buy the same amount no matter what the price change is, because that's the amount that I want. That's called perfectly inelastic demand. Now, if it's something that's in between, or do I have definitions for all these? Yeah, so it looks like this. I will give you pictures and I'll ask you, is this inelastic or elastic? You always know if it's perfectly inelastic because it looks like an eye. Inelastic starts with an eye, the graph looks like an eye. Notice that this is straight up and down. It's a straight up and down demand curve. That means elasticity equals 0 and it's a perfectly inelastic demand curve. Next, let's think, about unit elastic. What if it equals 1? So if it's in between 0 and 1, that means that it's inelastic. It's not perfectly inelastic. If electricity becomes $500,000, maybe people stop buying it then. But people still don't change much, right? The price of electricity goes up by 30%, and maybe we change how much we use electricity by about 5%. Or gasoline. If gas prices double, well, it's not that everybody stops driving. Maybe we drive 15% less, even if the price went up by 100%. So we have to look at these sort of situations when it's inelastic, if it's between 0 and 1. If it's equal to 1, this is a special case called unit elastic. So if the percentage change in the quantity demand equals the percentage change in price, this just means that we're unit elastic. Just a special word that notices that we have this one-to-one situation where, like, let's say that the price decreased by 6, we increase by 1 relative to what we're doing. So the price drops in half, we double the amount that we buy. Price doubles, we end up having it so that the amount that we're buying in total or demanding in total is halved. It's just that sort of relationship where we have this one-to-one situation. All right, so what's the general idea? Oh, and then if we get greater than 1, that's the elastic range. So if it's 4, that means that we're very responsive to a price change. If your favorite brand of sweaters goes on sale by 30% and you buy twice as many sweaters, that's being elastic. If your favorite pasta goes on sale by like 50%, it's half off, you buy everything on the shelf, right? That might be really elastic. If the price of these goes down by 25 cents and Dr. Plemmmons buys 5 cases of them because she has no self-control, that's in the elastic range. All right, so that's just the general idea that if the percentage change in the quantity demand is smaller than the percentage change in price, so for gasoline, if price doubles, but I only change by about 15%, If my percentage change in quantity demand is smaller than my percentage change in price, it's inelastic. If instead we see that the change in quantity demand is greater than the amount in price, so price goes up by 30% and the amount that I want doubles, so this percentage change in quantity is more than this percentage change in price, then we call that elastic. That's kind of cool, right? So if it's perfectly elastic, if it's the price changes at all, you stop buying it. So I'm willing, let's say that I'm willing to pay 50 cents for index cards. You charge me 51 cents, I don't buy any index cards. That's the idea of perfectly elastic, or no, excuse me. Yeah, because I want this one price. I'm very, very happy with this one price. I want to pay exactly 50 cents for these, and at 50 cents, I will buy all the ones that I possibly can. But if you change the price at all, I'm not going to buy them anymore. But if the price goes down, let's say that it's 51 cents. Oh, no, I dropped them. If the price of index cards is 51 cents, and I'm like, nope, too pricey for me, and they drop it down to 50 cents, then I'm like, ah, yes, please, everything that you have. It's like that Ron Swanson meme where he's just like, come back here. I think you misheard me. I want all the bacon and eggs that you have. You know, it's like that. It's having that sweet spot price where you're going to buy everything. And if it goes up, you stop buying. If it goes down, you buy everything. This is the perfectly elastic demand case. So there's three factors that are going to influence the elasticity of demand. So essentially what the slope of that line is going to be. Yeah. The first is going to be the closeness of substitutes. The second is going to be the proportion of your income that you're spending on the good. The third is going to be the time that's elapsed since there's been a price change. But at this point, we are making 3 different videos for this content, for this particular chapter. So I'm going to go ahead and let you be done for today. Please stretch your legs, get up, walk around, have some water. It's good for you. And I will have the other videos up soon. But spend some time thinking through this idea of the price elasticity of demand, what this actually looks like and what it actually means, because it's very, very important. And it's a concept that if you get it, the midterm is going to be much easier for you. If you have any questions, please come by office hours. I'm here to help you. That's literally my job. I'm here to help you succeed and learn economics. So please come talk to me if you need any help. Alrighty, I hope you have a wonderful end of your day.